How do computers see pictures? So, digital image data representation. So we see a picture. For example, we see this picture. How does your computer see it? Your eyes can pick out the picture, but this picture for the computer is actually broken down into a bunch of numbers. So computers see images as lots of numbers. This is what it sees. It sees pixels, RGB, that color, a pixel grid, and a background color. It can see different kinds of color. And we're going to talk about all of these terms throughout this topic. All right, so how a computer sees an image. So here's our image. What we're going to do is we're going to zero in on just a small little area. Let's say this little area. And actually, it's going to be even smaller than that, but I wanted you to be able to see it. All right, so let's see if we zoom in on our camera, what we start to see is what? What do you see here? Looks like a little checkerboard on here, doesn't it? Well, let's zoom in just a little bit more. So let's go and grab this area right here. And it's actually going to be smaller than that as well, but I wanted to put a box so that you could grab it. And this is what your computer sees. Notice that these little boxes or dots, depending upon how you want to look at them, these little boxes are broken up. And each one of these boxes represents one color. It's a single piece of data. One single color. That is a pixel. So if you can imagine this entire image, this whole image, is broken up into these little bitty boxes all the way through. That is how a computer sees your image. Because these are so small, you don't see the dots on the screen. Your screen has a good enough resolution to it, which it should. You're not going to see those dots. Instead, to your eyes, it looks like one continuous image. All right, so we need to understand color. To be able to start here, we've got to understand color. Now, what I want you to do is think back to the prism, right? Newton proved with this prism that white light is actually consists of pure and continuous colors. He identified the following colors, and you can see them here. Here they are right here. So there's red, there's orange, there's yellow, there's green, there's blue, there's indigo, and there's violet. These are the colors that he identified when he ran just this white light here, which is the visible light that we see around us. You run it through a prism. This is actually what it's comprised of. So each of these colors has a wavelength to it. You run it together, and what we get is just our natural white light that we see. You see this as well after a rainstorm, right? You'll see a rainbow, and because of the water droplets, it's able to accentuate and show you those waveforms. And it comes out by showing you the breakdown of that white light in the colors. All right, so let's talk about color encoding system. So the retina in our eyes has 3 types of color photoreceptor cone cells that can pick up certain types of frequencies. So I told you that color is a wave, and each one has a different frequency. And you don't need to necessarily know that what the frequencies are. However, I just want you to appreciate that it's a wave. And it has a frequency to it. That's what makes it a different color. Now, if we break those down, those categories that our eyes can see the best are red, blue, and green. Look at the pattern on this. Red, blue, and green. You use these colors every day if you're doing front-end development with CSS, because we're breaking them down into RGB. If you happen to be a designer, you're using RGB all the time, aren't you? Yes, this is a color encoding system. And by using RGB, we're able to get a variety of different colors by mixing those. All right, so what I'm going to do now is I'm going to switch over to a website. We want to play around with these colors here. So you can go ahead and type in this URL and go to this website. And what I want to do is I want you to appreciate these colors. So here, right now, everything is set to 0. See, the red is 0, the green is 0, and the blue is 0. What do we know about 0? What does that mean? 0 means no value. There's nothing there. So we get a black color. If I take the blue all the way up to the end, what do I get? I get blue. See the color blue here? And notice that my number changed to 255. What do we know about the range 0 to 255? Come on. It's 1 byte, isn't it? So each of these is a byte of data. If I go and I take the green all the way up, and I take the blue back down so you can see. So now the green is all the way up. See, I'm at 255 and I have green. If I bring it down just a little bit, notice that my green is getting darker and darker and darker and darker and darker and trying to go all the way back to black. Let's do that with the red. If I go all the way up, I get red. I'm at 255. Now I can start dialing that back a little bit and notice that my red is fading away to black. So it's getting darker and darker. Well, let's just do a mixture. Let's go to here and let's go to there. Let's see what ugly mixture that we can make. And we'll go to here. So you can see just by changing these values, we can make an assortment of colors. You see that? That's the encoding system. Just by using these 3 colors and varying between 0 to 255 on each one, we're able to come up with a full palette of colors. So using 255, which is 1 byte per color on our red, green, and blue, so that would be how many bits? How many bits do we have? We have 8, 8, and 8. 8 times 3 is 24. So we get what's called true color, which is a 24-bit color depth. And did you know that at that 24-bit, that's more than the human eye can see? So it should be more than we would need to be able to encode any picture that we want to see. It's a good system for converting a picture over into digital format. All right, let's talk more about the pixel. So here is a pixel. This is a red color. Notice that it's our true red. It's a 255, and we have 0 and 0. I also gave us the hex representation for that. So you might be actually using the hex within your CSS. But you also have the option to use the RGB version as well for the encoding. So let's talk about this one pixel, and notice that it's a very large pixel. So we'll take this tiny piece of information. It represents one color, right? The color can be represented in hex or hexadecimal, a decimal set, so that's our base 10 of red, green, and blue, the RGB. That's what we have here, RGB. But it can also be broken down into binary. The computer's going to break it down into binary. So at 255, that would be a byte of all ones. At 0, that would be a byte of all zeros. What we'll end up with is a byte, and a byte. So we'll have 3 separate bytes. So let's break this down. What we're going to do is convert this hex number over into binary. Let's go ahead and do that now. Here's our hex number. Here's hex notation. And what we're going to do is we're going to take that F, that first F, and bring that down, and we're going to convert hex into binary. We know that hex has a grouping of 4 bits, correct? So therefore this F is a 15. That would mean that these are all ones. Let's go ahead and fill that in. That's all ones. Let's bring down this other F. Okay. And this one should be easy. It's all ones. So we went ahead. Let's go ahead and bring down the 0. Well, this is easy. These are all 0. And we'll just continue on. We need the next 0, the next 0, and the next one. So let's go ahead. And there you go. This is the binary representation of the color red. So you can see right from here, we've got 3 different types of representation. This is what the computer sees. This is the hex that you'll be putting into your CSS, or you might also be putting it in as an RGB number, as you see here with the decimal version. All right, let's talk about the color representation. So we're going to stick with our red pixel here. So we have a base, we have a red, we have a green, and we have a blue. So let's go ahead and lay this out. So for decimal, that would be 255 for red, right? The green is 0 and the blue is 0. Then for octal, see, I didn't cover octal, did I? That would be 377. So 377 would be the red. The green is 0. The blue is 0. For hex, the red is FF. The green is 00. The blue is 00. For binary, it breaks out to all ones in the byte for red, all zeros for green, and all zeros for blue. Now, let's just stop right here. We've been dealing a lot with data representations, and this one table shows you all the representations. Now, I'm hoping by now you're understanding what the impetus is here, that this 255 is the same as 377, and octal is the same as FF and hex, and all of these are representations of this binary. Your computer works down here in the ones and zeros. Each of these are a representation of that, and they're all equal to one another. You can use FF in place of this binary. You can use the 255 in place of the FF. Okay, so let's understand a pixel grid. So when you look at a picture, you're not seeing just the individual pixels, right? Instead, there is a grid of pixels all the way across that picture. We need to understand how the computer maps that grid. So here's an image. And what we're going to do is, if you try to remember back when you were in school and you see this layout, this will be a coordinate system. It's also based on a grid system, so it's laid out in a grid. So what you need to think about is back when you were mapping dots in a coordinate system and then figuring out the line and the slope of that line. So here we go. This is the x-axis, and each one of these pixels or squares represents a position on that line in the x-axis. So it goes from 0 all the way up, and it goes in a positive number. So it would be 0, 1, 2, 3, 4, 5, and on up. All right, so this is the y-axis. And again, we're going to start at 0 and move our way down. You can see we go 0, 1, 2, 3, 4, 5. All right, so up in the top left-hand corner then, that position is 0, 0. So let's take a look at this one. Let's look at this pixel right here. We know that a pixel is holding one piece of data. It's holding a color, and we know that that's going to be an RGB. That's how it's encoding it. All right. How does it identify that it is this pixel? This pixel's yellow. Well, it comes in, it says, we want to have a coordinate system, which is x-axis 1, y-axis 1. And then it will have the color encoding. So let's go ahead and do this one. We have the coordinate as 1, 1. And then here is the color. So this tells us where the position is at, and this is the color that goes to this position. So this is the data that is held in this position. Let's go and look at another one. Let's take this green down here. So this would be a 0 and 5. 0 and 5, and here's the color. Let's do one more. Let's do this one right here. So this would be a 5 and a 2. 5 and a 2, and here's the color. Do you see how the pixel grid works? So if we look at this picture that we had before, and what I want you to picture is up here. Let's say this corner up here is 0, 0. Right? So this is our x-axis. This is our y-axis. And if we say this is 0, 0, and each one of these little bitty dots here gets encoded with one single color. So you can picture here's all the x's, and it's going to go row by row by row by row all the way down until it's encoded this entire picture. So the one thing that we haven't talked about yet is how do we determine resolution? You know resolution. You hear about it not only in your monitor that you're looking at right now, but also in the pictures that you're putting up for your websites and in the cameras that you use. So when you look at a camera, it's telling you what type of resolution that it has. So let's understand that. Here's the formula. Resolution equals the number of x-axis pixels times the number of y-axis pixels. Okay, that makes sense. So it's then going with the width times the height. So here's a picture. And this has a width of 400 pixels. And this has a height on the y-axis of 400 pixels. So therefore my resolution would be what? Go ahead, figure it out. Resolution equals 400 times 400. If I break that down, that's 160,000 pixels. And roughly that's 0.2 megapixels. So when you see your camera, whether it's on your phone or maybe you have another digital camera and it tells you that it's a 5 megapixel, a 0.2 megapixel, whatever that value is, that's what it's telling you is your resolution. All right, so what are our takeaways? Digital images are comprised of tiny amounts of information. The pixel is that unit of measure for a digital image. One pixel represents one single color. It's holding one piece of information, that single color. Colors are represented in hex, RGB, and other identification schemes. We covered the RGB here and hex. Pixels are identified by their location within that coordinate pixel grid.